In this problem, we're asked to sketch the graph of y equals negative log base 3 of x plus 2. So rather than plugging in points, which could be a little tiresome, we're going to start with a graph that we should know how to graph. So we're going to start with the graph of log base 3 of x. And then we'll apply some transformations to it. So the very first thing that happens to our input x is we add 2 to it. So adding 2 inside of a parentheses directly to the x will move the graph to the left 2 units. So we'll shift left 2. And then the next step is going to be to take care of this negative. And since the negative is on the outside and not directly in front of the x, this negative will correspond to a reflection across the x-axis. So we'll reflect across x-axis. So let's see if we can do this process. So we'll start with the graph of log base 3 of x. Any log graph has an x-intercept of 1, 0. And because it's log base 3, that means when x is 3, y is 1. Because the 1 is the power we'd raise 3 to in order to get 3. Log graphs also have this similarity. There's a vertical asymptote along the y-axis. And then the general graph looks like this. That's what we're going to start with. We're going to shift this over to the left 2 units. So we take this point here at 1, 0, and this goes to negative 1, 0. This point at 3, 1 goes to 1, 1. And now what's important to notice is that this vertical asymptote at the y-axis also gets shifted over. So we get a vertical asymptote along the line x equals negative 2. So if we keep that in mind, connect the dots, there's the graph shifted over 2 units. The very last thing we want to do is reflect across the x-axis. So this point here at 1, 1 goes to 1, minus 1. This point at minus 1, 0 stays at minus 1, 0. And then the tail that goes down to minus infinity along the vertical asymptote is going to start up at positive infinity and come in like this. So there's our final graph of y equals negative log base 3 of x plus 2. One thing to note before we end is that this should match our domain that we found in the previous problem, and it does. All the x values that are in this graph are larger than negative 2.